Now, let us understand factor analysis. So, factor analysis, we apply it to set of observed variables. Then we find underlying factors from which the observed variables were generated. Say, for example, the individual response to test questions can be influenced by the amount of practice taking tests, the age, intelligence, and so on. So, when the answers to the questions are the observed variables, however, the underlying influential variables are the factors. So, the goal of factor analysis is to aid with data interpretation and also reduce the number of variables. However, factor analysis is different from principal component analysis. We will later look into the slide where we look more into how is factor analysis different from PCA. Now, let us look into some mathematics in factor analysis. So, factor analysis is a method for investigating whether a number of variables of interest, say for example x1, x2 to xp, they are linearly related to smaller number of unobserved factors. Okay, so that is a mathematical presentation of factor analysis. So, which means that the observation of the random variable xi is influenced by some unobservable factors, which is f1, f2 up to fm. Okay, this will make much sense when we are doing the interpretation. Now, let us understand how it look like the model. So we have observed random variable and we have factors, of course, and the loadings and an error. So call it a specific factor. So all these components of the factor analysis model, they come together with some assumptions and also some few rules. So as I did mention that statistical methods come with assumptions. So factor analysis also has assumptions. So I am not going to go through all of them, but it has quite few assumptions. So for example, the xi's variables, they are normally distributed with variance 1 and preferably the mean of 0. So these are all the factor analysis assumptions. So let us look into the example. How can we carry out factor analysis, like some mathematical background in it? So let's say there are students entering a certain program. They must take 3 required courses in finance, marketing, and business policy. So X1, X2, and X3, they will represent students' grades in these courses. So say they get marks out of 10. So there is a sample of 5 students. So, so these are the marks of students. Now, say for example, this is the factor analysis model that we obtained after doing an analysis. So let us look here is that we have x1, which is heavily loaded on the second factor, which is this one, f2, but not so much on this first factor, right? If we look into marketing and policy, they are heavily loaded on this first factor, but not so much on the second factor. So intuitively, we can say that, okay, the first factor is a communication factor. So it is highly associated with marketing and policy, which are subjects associated with communication skills. But if we look into F2, which is heavily loaded on, if we can look into X1, so X1, which is finance, so it's heavily loaded on the second factor. So we can say that this second factor is a quantitative or a financial skill we can say that this factor is a quantitative or financial skill factor since it is associated with finance. So, SAS provides us with a procedure, factor procedure. So, we use factor procedure to actually perform factor analysis. So, we will eventually have to add if we want to specify some specific method for a rotation. So when we want to obtain orthogonal solution, for example, Varimax solution, Quatermax, and others. So oblique solutions are also available, right? But when it's come to retaining and interpretation of factors, we don't interpret all of them. However, we can also make use of eigen one, eigenvalue one criterion, right? Where we retain and interpret any factors with an eigenvalue greater than 1.